Welcome! Here we're talking about scientific notation today, so please get this homework sheet started by putting your name at the top left and the date at the top right. And make sure you have that title because here we go. Scientific notation allows us to write very large and very small numbers in a limited amount of space. So I mentioned this in class to some of you maybe, the fact that sometimes, especially in matters of science, we're talking about extremely large distances or extremely small masses, and it would be annoying to write at these huge or tiny numbers over and over again with a bunch of placeholder zeros to get us to the right place. So instead we have scientific notation. A number in scientific notation always has two parts. The first part is a number which is less than 10 but greater than or equal to 1, so like 3 and 45/100ths, or 7 and 1/10, or 9. But it has to be greater than or equal to 1 and at less than or equal to 10. An easy way to think about this is the decimal is always after the first digit, and the first digit is not a 0. So if the decimal is after the first digit, then it can't be greater than 10, and if it's not a 0 to start, then it has to be greater than or equal to 1. The second part is that scientific notation always has a multiplication by 10 to a power or an exponent, and this is going to tell us where we move that decimal to find this, to express this really large number that we're trying to condense, or this really small number. So multiplying by 10 to a power allows us to know that we're dealing with something that's a lot bigger or a lot smaller, but we just don't want to show the difference in place values in the natural way, in standard form. So you can see that I gave an example right here. It's 4 and 25/100ths times 10 to the 13th power. Now 10 to the 13th power means we're going to multiply by 10 13 times. And you probably know that every time you multiply by 10, the place values shift, and the decimal kind of moves. It really doesn't move, but the decimal moves once to the right every time you multiply by 10. So we're going to move this decimal 13 times to the right, and we would have a really big number. So you can see why that'd be annoying to write out. Instead, we have it in scientific notation. So I have a couple examples of what sort of scientific notation questions I could ask you, or you will be expected to know in the future. So the first one says, write in standard form. Standard form just means standard, like what we're used to seeing. So this is 2 and 38/100ths times 10 to the 8th power. I mentioned earlier that we know that whenever you multiply by 10, the place values shift and you move the decimal once to the right. So that's going to happen 8 times. We're going to multiply by 10 8 times, and so the decimal is going to move. Our place values are going to shift 8 times. So I know that it'll move twice. To write this in standard form, it'll start with the 2, a 3, and an 8. I've already moved it twice. I need to move it those 6 other times. We'll need placeholder zeros. And my commas just so it's easier to know the place values. So 2 and 38/100ths times 10 to the 8th power is actually the same as 238 million. That's just a little different way to write it. Number 2 says, write in scientific notation that's 68,700,000,000,000. And so we know that, well, that's a lot of zeros to write. If we write in scientific notation, we can do without writing those zeros. So if you remember, the first thing we need is a number that's between 1 and 10, or we can put our decimal after the first non-zero digit. So we know, I can just think about it. We're going to put the decimal right there, and it would say 6 and 87/100ths. Now we're going to multiply by 10 to an exponent. And if now our decimal is between the 6 and the 8, how many times are we going to need to multiply by 10 to be expressing this exact same number? So if it's right here is where we put it, then we're going to need to multiply by 10 once, twice, 3 times, 4 times, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. So this will be times 10 to the 13th power. The third example we have says the Earth is 92,960,000 miles from the Sun on average. We know that the Earth has an elliptical orbit, so it's not always the same distance from the Sun, but on average, it is 92,960,000 miles from the Sun. Write this number in scientific notation. Okay, again, we know that we just need the decimal after the first digit, and then all these other ones are meaningful because, you know, if I'm just multiplying by 10 to a power, that 2, 9, and that 6 won't appear out of nowhere. I would just think they were placeholder zeros. So I need to include those so we know that we're not just filling in these place values with zeros. So we include all of the non-zero digits in that first number. And then we need to multiply by 10 to an exponent. So how many times am I going to need to move this decimal, or how many place values have we shifted it? And we've shifted, and another way to do this is just to say we shifted it 3 in the first period. We shifted it 3 more, or 6, and then a 7th. So we multiplied we can multiply by 10 7 times. And this is the number of miles that Earth is from the sun on average. As always, I'm going to leave you with some examples to do on your own, some practice, so please get these done. The first one says write in scientific notation, so convert that to scientific notation, knowing what you know about what scientific notation needs. The second one says write in standard form, so you can multiply by 10 a lot, or you should know a trick about how to do it more easily. And the third one says Pluto is 3 67/100 times 10 to the 9th power miles from the sun on average. Write this number in standard form. So I want the big number. How many miles? Write it out as a normal number. Best of luck, and I will see you tomorrow in class. After I turn off this video. Now.